first glance, a mortar seems almost primitive compared to fighter jets, cruise missiles, and advanced artillery systems. Yet for more than a century, this deceptively simple weapon has remained one of the deadliest and most effective tools on the battlefield. From the trenches of World War I to the battlefields of Ukraine, Gaza, Iraq, and countless conflicts around the world, mortars continue to deliver devastating firepower with remarkable simplicity. But how does a mortar actually work? What happens inside the tube when a round is dropped? Why does a weapon with technology dating back generations remain so important in modern warfare? Today, we're breaking down the complete mechanism of a mortar system, from setup to firing, and explaining why this weapon remains one of the most feared indirect fire systems ever created. A mortar is an indirect fire weapon designed to launch explosive rounds at very steep angles. Unlike a rifle or tank gun that fires directly at a visible target, mortars send their projectiles high into the air before they descend onto the target from above. This allows mortar crews to strike enemies hidden behind buildings, hills, forests, defensive positions, natural terrain obstacles. A typical mortar consists of only 3 major components. The barrel or tube. This is the long metal tube through which the mortar round travels. The base plate, a heavy metal plate resting on the ground. Its job is to absorb the enormous recoil forces generated during firing. The bipod, the support structure that stabilizes the weapon and allows crews to adjust elevation and direction. Simple, portable, reliable, and incredibly effective. The mortar shell itself is a carefully engineered piece of ammunition. At the front is the explosive warhead. Inside are high explosives designed to create blast and fragmentation effects. At the rear are stabilizing fins. Unlike bullets, mortar rounds do not spin rapidly. Instead, the fins keep the projectile stable during flight. Attached near the tail section are propellant charges. These charges determine how far the projectile will travel. Need a short-range shot? Use fewer propellant increments. Need maximum range? Add additional propellant charges. This flexibility allows mortar crews to adapt quickly to changing battlefield conditions. The fuse at the front determines when the round detonates. Some explode on impact. Others detonate above the target. Certain specialized rounds can even create smoke screens or illuminate the battlefield at night. They're soldiers deploying a mortar team. Before firing can begin, the mortar must be properly positioned. The crew first selects a firing location. The base plate is firmly placed into the ground. This is critical because firing generates substantial force. Next, the tube is attached to the base plate. The bipod is installed and adjusted. The crew then aligns the mortar using maps, compasses, laser rangefinders, GPS systems, or fire control computers. Modern armies often use digital targeting systems that calculate firing solutions within seconds. Older systems relied entirely on manual calculations. Regardless of technology, accuracy depends on precise setup. Even a small mistake can cause rounds to miss by hundreds of meters. Now we arrive at the most fascinating part. How does a mortar actually fire? Unlike many weapons, most traditional mortars use a remarkably simple mechanism. At the bottom of the tube sits a fixed firing pin. The mortar round is loaded from the muzzle, the open top of the tube. The gunner carefully drops the round into the barrel. Gravity immediately takes over. The round slides downward through the tube. As it reaches the bottom, a primer located in the tail section strikes the fixed firing pin. The impact ignites the primer. The primer ignites the propellant charge. The propellant rapidly burns and produces high-pressure gases. These expanding gases push against the base of the mortar shell. Within milliseconds, the projectile is accelerated upward and exits the tube at high speed. The entire process occurs almost instantly. No trigger pull is required on many conventional mortar systems. The simple act of dropping the round initiates the firing sequence. This simplicity is one reason mortars are so reliable under combat conditions. Few moving parts mean fewer opportunities for mechanical failure. Once airborne, the mortar round follows a ballistic trajectory. The projectile climbs steeply into the sky. Gravity gradually slows its ascent. Eventually, it reaches its highest point. Then gravity pulls it back toward Earth. The shell descends onto the target area from above. This high-angle attack is one of the mortar's greatest strengths. Many battlefield positions are protected from direct fire. but very few are protected from explosions arriving almost vertically from the sky. When the fuse activates, the warhead detonates. The explosion creates blast pressure, high-speed metal fragments, shock effects, structural damage. The result can be devastating against exposed personnel and lightly protected positions. Modern mortar teams operating in various environments. In an age of drones, precision-guided missiles, and advanced artillery, many people assume mortars would be obsolete. The reality is exactly the opposite. Mortars remain valuable because they are cheap. A mortar round costs far less than a guided missile. Portable, infantry units can transport them into areas inaccessible to vehicles. Rapid, a trained crew can deploy and begin firing within minutes. Reliable, their simple design minimizes breakdowns. Effective, they provide immediate fire support to troops engaged in combat. Modern armies continue investing heavily in mortar systems because they deliver a powerful combination of mobility, affordability, and battlefield effectiveness. In many conflicts, mortars account for a significant portion of indirect fire support. Their importance has not diminished. If anything, modern warfare has proven their enduring value. The mortar is one of the simplest military weapons ever designed. Yet beneath that simplicity lies brilliant engineering. A tube, a baseplate, a projectile, and the laws of physics working together with remarkable efficiency. For more than 100 years, this weapon has supported infantry forces around the world, delivering firepower where it is needed most. Whether on the battlefields of the past or the conflicts of today, the mortar remains a powerful reminder that effectiveness does not always require complexity. Sometimes the most enduring military technologies are the simplest, and the mortar is perhaps one of the greatest examples of that principle ever created. Thank you to our supporters. Before we end today's video, we want to extend a huge thank you to every single person who supports this channel. Whether you've subscribed, liked a video, shared our content with friends, left a comment, or simply spent your valuable time watching our documentaries, your support makes all of this possible. Your encouragement allows us to continue researching, producing, and sharing in-depth content about military technology, history, strategy, and the evolving nature of modern warfare. To our loyal subscribers and returning viewers, thank you for being part of this incredible community. If you enjoyed this video, don't forget to like, subscribe, and turn on notifications so you never miss future content. Until next time, thank you for watching, stay curious, and we'll see you in the next video.